Okay.
What office?
We're going to start a new unit today on systems of equations. And mainly we're going to focus on how to solve a system by graphing the two equations. All right? So the objective of the lesson is to determine whether an ordered pair is a solution of a system, to graph a linear system, and to find the solution by graphing. All right, a system of linear equations is a set of two or more linear equations with the same variables. All right, a solution of a system of linear equations in two variables is an ordered pair. That is a solution for each of the equations. All right, so basically the solution is the ordered pair x and y. If you plug it into either one of the equations, it's going to work. So let's look at this example. They're wanting to know whether the ordered pair 5, 3 is a solution to the system below. All right, this is the system. We got more than one equation. And they're saying, is this ordered pair, this x and y, will it make both of these statements true? So what we're going to do is to plug in and replace or substitute x with 5 and y with 3. And now, is that correct? 5 plus 3 equals 8. Yes, it's true. So that means that 5, 3 is a solution for that equation. So now we're going to try the second one, and we're going to replace x and y with 5 and 3. So 5 minus 3 equals 2. Well, that's true as well. So this ordered pair of 5, 3 satisfies both of the equations as being true. So yes, this is a solution. Okay, let's look at another one. We have the ordered pair, x is 2 and y is 4. So again, we're going to substitute x and y. So 4 times 2 minus 4 equals 7. So 4 times 2 is 8, and 8 minus 4 is 4, not 7. So this is not correct. So we can stop there. No, it's not a solution because it doesn't satisfy both of the equations. All right, and then let's look at the third example. Again, ordered pair. They're asking, is that a solution? So we're going to replace x, substitute 2 for x, and 4 for y. So 2 plus 8 equals 10. Well, that's true. All right, so far so good. Let's look and substitute in the second equation. 3 times 2 minus 4 equals 5. So 3 times 2 is 6 minus 4 does not equal 5. So no, this one's not a solution either. Okay, so yeah, you can see if it's a solution. If they satisfy all of the equations, then you're good. All right, the way we can find a solution to a system is by graphing both lines. All right, so these are already in slope-intercept form, which is the preferable way to graph. So on the first equation, my slope is 1, and my y-intercept is b, the negative 8. So I'm going to go to negative 8, 2, 4, 6, 8, make a point. Then I'm going to use my slope 1, or 1 over 1, and rise over run. So I'm going to go up one to the right one, and I can keep doing that and go on out. Or I can go do the opposite, -1, -1, which is positive, and make a point. So there's my graph of that line. Okay, now we have to graph both of them. So this one, my slope is -2/1, and my y-intercept is +1. So +1, I make my point, and then my slope is -2/1. So I'm going to go down 2 and to the right 1, down 2 to the right 1, down 2 to the right 1, down 2, right 1. Or I can do the opposite, 2/-1, that's the same as that. So up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And now I have my line. Now, you say, okay, well great, you graph 2 lines. We're looking for a solution. This point where they intersect at 1, 2, 3, at 3, x is 3, and y is 1, 2, 3, 4, 5, -5. That point is a solution. Okay, where they intersect, these 2 lines intersect, is that point. And you can test it by substituting. So if I replace y with -5 and x with 3, -5 equals -5, so that's good. I can test it with the other. -5 equals -2 times 3 plus 1. So this becomes -6 plus 1 is -5, so that works. So you can always check it and make sure that way. Okay, but wherever your 2 lines intersect is your solution. This is where you have to make sure. Our last unit was graphing linear functions, so that's why we need to make sure that we mastered that skill of graphing a linear function. All right, the next one. This one's already in slope-intercept form. This one is not. I can put it in slope-intercept form, or I can get the x and y-intercept. But let's just go ahead and put it in slope-intercept form. I'm just going to swap places with these 2 and make it x minus 2 equals positive y. All right, so I'm going to graph this line, and let's make this line red. X plus 5, so 1, 2, 3, 4, 5. My slope is 1, so we're going to do a slope of 1 by going rise over run, up 1, down 1. So here is my line. And so we've graphed that one. Now let's do this one. So my y-intercept is -2, my slope is 1. All right, so up 1 to the right 1, down 1. I may not have enough room. Well, you look at it and you say, well, this isn't going to intersect, is it? They're not going to intersect, are they? Do you think they'll ever intersect? Well, what do we know about them? This one has a slope of 1, and this one has a slope of 1. Well, what do we say about same slope? Those are parallel, aren't they? So they never intersect, do they? Oops. So there's no solution. If they have the same slope, that means they're parallel, and and they're never going to intersect, so there'll be no solution. Okay, well, let's look at another one here. All right, these are both in standard form. I'm going to go ahead and put them in slope-intercept form. So we got 3x minus 5y equals negative 35. I'm going to get rid of this 3x. So I got negative 5y equals, and I like my x in front. So now I get rid of the negative 5 by dividing. Negative 5 divided by negative 5 is 1. So now we got a positive y. But whatever I do on one side, I have to do on the other. So y equals negative divided by negative is positive 3 over 5 x plus 7. Okay. And let's do the other one. 2x plus y equals negative 6. We're just going to bring this over, minus 2x minus 2x. So y equals negative 2x minus 6. All right, well, they don't have the same slope, and it's not the opposite reciprocal, so we're not going to have a problem here. Well, perpendicular would be okay. That would intersect, wouldn't it? But they're not the same slope, so we know we're going to have a solution. Okay, so let's look at this one. Let's make this one blue. So plus 7, 2, 4, 6, 7. Our slope is 3 over 5, so up 3, to the right 5. Or we can do the opposite, down 3, to the left 5, down 3, to the left 5. So we have our line here. And I apologize, mine's off the screen a little bit. Okay. And let's make this one's going to be red. So 2, 4, 6. There's your y-intercept. And our slope is negative 2 over 1, down 2 to the right 1, or the opposite, up 2 to the left 1. We need to carry that on out because we need to intersect, don't we? And we did. Okay, so we are intersecting right here at, those are kind of blurry there. This would be at, let's see, 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4, 4. So that is my solution. Okay. Got another here. Oh, what is this? There's not a y, so that's, if you only have one variable, it's either going to be vertical or horizontal. And this one will tell you, cross the x at negative 2. So I'm going to go to negative 2 on my x right there, and I'm going to cross it. So I got a vertical line right here. All right, let's put this one in slope-intercept form. So negative 2y equals negative 3x minus 18. Divide by negative 2. So y equals positive. Be careful with your signs. Negative divided by negative is positive 9. So my y-intercept is 2, 4, 6, 8 is 9. And my slope is 3 over 2. Go up 3 to the right 2, or we can go down 2 and to the left 2. So we can see that that our intersection is right here. And this is at negative 2, 2, 4, 6, negative 2, 6. And that's our solution. Okay. All right, let's look at a few more. All right, these are both in slope-intercept form, which is awesome. Slope, my y-intercept's 9, and my coefficient of x, my slope is 1 over 2. So I go to 9, 2, 4, 6, 8, 9. It's my y-intercept. Slope is up 1 to the right 2, or the opposite, down 1 to the left 2. Okay, so that's going to be my line. And then we're going to graph this one. Y-intercept is 6, 2, 4, 6. And my slope is negative 1, down 1 to the right 1, or up 1 to the left 1. Woo. All right, so you can see we're intersecting right here at negative 2 and 8. So that's your solution. And some of you probably need to practice on converting standard form to slope-intercept form, which is this right here. Remember, standard form, you got x and y on one side, so we just need to isolate that y. So we're going to add 3x to both sides. Same thing here, add x. Okay, so for this one, my y-intercept is the constant 8, 2, 4, 6, 8, and my slope is 3. Up 3 to the right 1, or the opposite, down 3 to the left 1. And again, I just carry it on out. 1, 2, 3, 1, 2, 3, 1, down 3, left 1, down 3, left 1. So now I have my graph. Okay, and then graphing this one, my y-intercept's negative 2. So I'm going to go to negative 2, make a dot. And my slope is coefficient of x, which is 1, 1 over 1. So up 1 to the right 1. And I'm just going to carry this out. Or go down 1 to the left 1. There we go. There's our answer. Okay. So my solution is this point right here is where they're intersecting. And it is at 1, 2, 3, 4, 5. So negative 5 is my x. And my y is 1, 2, 3, 4, 5, 6, 7. Negative 7. Okay. All right, this one, let's move the x to the other side. And then we're going to divide by 3. Everything by 3. So we got y equals, this is negative 1 divided by 3x. And negative 15 divided by 3 is minus 5. And then here, we don't have an x, so that says cross your y-axis at negative 7. So 2, 4, 6. So here's negative 7 on my y-axis, and I'm going to cross over it, making a horizontal line. And then this one, y-intercepts negative 5, down 1 to the right 3, down 1 to the right 3. So we can tell already there's our intersection is right here. And this is at 2, 4, at 6, and this is -7. So there's your answer. And again, you can substitute these x and y values of your ordered pair into these, and they will be a solution. Let's move this over, and then divide everything by 4. So you get y equals -8 divided by 4 is -2x. -16 divided by 4 is -4. And this one's already. So let's graph this one first. Our y-intercept is a constant, -4, 2. And then my slope is -2. Coefficient of x is your slope, right? So I'm going to go down 2 to the right 1. Or the opposite, up 2 to the left 1. Okay. So there's my line, crooked line. And then for this one, my constant, my y-intercept's -4. We got the same, look at there, same. So that's, we know it's going to intersect. Oops, my bad. No. What? Look at that. They're the same, aren't they? Well, what happens when you have the same? What happens? Well, if I graph that, we're going to have the same line, right? So where are they intersecting? Well, they're intersecting everywhere. Every point on that line, they're touching, they're intersecting. So this was going to be infinite solutions. They're the same line. So they are intersecting at every point on that graph. So there's infinite because it keeps going and going. Okay. All right, let's look at this one. This one's already in slope-intercept form. This one, let's get rid of this. Oops. Let's move this x over. And then we're going to divide everything by -3. So this goes away, and we got positive y equals, we'll do our x first. -9 divided by -3 is positive 3x. 15 divided by -3 is -5. So now this is my second equation, this is my first. What do you notice about these? They've got the same slope, don't they? And remember, we did one earlier. Same slope means they're parallel. So if they're parallel, they're never going to touch. So it's no solution. We don't even have to graph it because we know they're parallel. And they'll never touch, so no solution. I like those. Those are short and easy. All right. Let's put this one in slope-intercept. -x, -x. Then we're going to divide everything by 2. So y equals -1 divided by -2 is positive 1 over 2x. 4 divided by 2 is 2. And you say, whoop, we got the same. Well, no, this one's positive 1/2 and this is negative 1/2. They've got the same y-intercept, don't they? So you know that if this one's up 1 to the right 2, it's going to look like this. And then the other one's down 1 and to the right 2. It's going to look like this. And where are they crossing? At their y-intercepts because they're the same. So my solution is my y-intercept 0, 2. Okay, so if you've got a system and they've got the same intercept, you know they're going to be That's where they're going to touch. They're going to intersect there. Okay. All right. Okay, let's look at a little bit of application here. And I want you to look at your calculator too. Okay, a contractor buys 15 gallons of paint, 15 gallons of paint, and 8 tubes of caulking for his total of $640. All right. And then another contractor buys 8 gallons of paint and 2 tubes of caulking for $296. Find the price of a gallon of paint and a tube of caulking. All right, so this is what we use systems for. Well, we've got two different things like this going on. We're doing the same thing, except it's a different amount. Like if Johnny went to Dairy Queen and bought 3 hamburgers and 4 hot dogs, and he paid such and such amount. And then Brad went to Dairy Queen and bought 4 hamburgers and 1 hot dog, and he paid such and such amount. By knowing that, we can find out how much the hamburger and how much a hot dog cost, based on them getting charged the same amount per hamburger, per hot dog. All right, so we first need to write our equation. So we're going to say that the price of paint is going to be X, and the price of caulking is going to be Y. Okay, and that's what they said. That's our unknown. Find the price of a gallon of paint and a tube of caulking. That's what we're trying to find out. That's our unknown. That's our variables. So always define them first. So let's look at the first contractor. Okay, he bought how many gallons of paint? 15. So if I said 15 times how much ever it costs for that paint, that would tell me how much he spent, right? Plus, he bought some caulking. How much? 8. He bought 8 tubes of caulking, and he paid a total of that was $640. Okay, because he bought 15 times the price of paint plus 8 times the price of caulking equals $640. So there's contractor A. Then contractor B, he bought 8 gallons of paint plus how much? 2 tubes. Oops. Oh, my pen's not working. There we go. 2 tubes of caulking, and it cost him $296. So this is contractor B. All right. Now, we're going to graph this in our calculator. Okay. So you need to get them in slope-intercept form first. All right. So I need to bring the X over. Got a little space here. So let's say 8y equals negative 15x plus 640. And then we're going to divide everything by 8. So y equals negative 15 over 8 plus 640 divided by 8 is 80. Okay. Our second one would be, if I bring that 8x over would be 2y equals negative 8x plus 296. Divide everything by 2. So y equals negative 4x plus 148. So put these two in your calculator. Okay. Let's see. Well, I can't pull it up on here. But if you go to your calculator, go to y equals, up on the top left button, hit that, and then put this one in your, type in, use your fraction key, or either do parentheses, negative 15 divided by 8 parentheses plus 80, and then hit enter, and then put in negative 4x plus 148. Press your graph key, and you're going to see your graph. Now, if you will follow these little steps, enter both equations, press graph. You may have to zoom in or out, but you need to see your intersection, okay? It's kind of, since these are big numbers here, 640 and 296, it's going to be kind of hard just to look at it and see what the intersection is. But we're going to use a little function that we can do, a little, if we press second and then trace, second and trace, then press 5 because it says intersection next to the number 5. All right, you'll see it says intersection. And then you're going to press enter 3 times. And when you do that, you should get 3220 is your intersection. X is 32 and Y is 20. Okay, you may have to pause this video and play with your calculator a little bit, but if you do that, this should be what you get. Make sure you've entered your equations correctly. Okay. All right. Let's again play with it and see how you do. So make sure you can do that on your calculator, because you surely don't want to have to do the math on this right now. All right, let's look at another one. Carol buys 2 hamburgers and 3 hot dogs for $22. So we're going to say 2 hamburgers and 3 hot dogs for $22. While Tristan, he's going to buy 8 hamburgers and 5 hot dogs for $60. Find the cost of the hamburger and hot dog. So that's our unknown, the cost. So X is going to be the cost of a hamburger, because that's what we're trying to find out here, right? So always write this down. Okay. And the cost of a hot dog, we're going to say is Y. So the cost of a hot dog. Now, when you're doing these type problems, if you put hot dog in place of hamburger, it'll still work out as long as you keep both of them the same when you're writing your equations. All right, so let's write our equations. Let's do Carol. Okay, so Carol, she brought 2 hamburgers, and cost of hamburgers is X, plus 3 hot dogs, and the cost of hot dogs Y, and she spent $22. Okay. Whereas Tristan, okay, she bought, okay, sorry, had announcements. All right, Tristan, let's see, we got 8 hamburgers and 5 hot dogs. They paid $60. All right, so again, you can put this in your calculator. We need to put them in slope-intercept form. So 3y equals negative 2x plus 22. We're going to divide everything by 3. So y equals negative 2 over 3x plus 22 divided by 3. You can put the decimal there for your y-intercept. That's fine. Not a problem. I just like fractions. I know I'm crazy. All right, 5y equals, bring the 8x over. And we're going to divide by 5. So y equals negative 8 over 5x plus 12. So put those both in your calculator. Follow those directions. Graph it, second and trace. 5, enter, enter, enter. And you'll get your solution of 5, 4. Now, see how it would be beneficial to use your calculator for this? Because graphing that 22 over 3 is the y-intercept, it's going to be kind of hairy, all right? So calculators come in handy, save a lot of time, okay? Now on test, you'll be able to do both of them. Sometimes I'll say graph it, sometimes I'll say using your calculator. Okay? All right, that's it for this lesson. See y'all later.